Mattia Pizzirani from FOSS SPA talk about a very interesting development and using Raspberry Pi, right, in industrial environments and how they compare to regular PLCs.
Hi everyone. In these 10 seconds, I would like to thank the Norway Tech Park for orchestrating all this event. And I would like to thank my company that allowed me to be here today. So, without further ado, I would like to talk about Raspberry Pi and Node-RED as useful tools for automation and industrial IoT applications. I will just make a little bit of a prologue talking about IoT and what it actually is IoT and industrial IoT. IoT refers to the broader network of connected devices used in everyday life that we use, like smartwatches and home appliances, stuff like that. And the goal is typically to improve the quality of life of an end user, as all of us are. When we go industrial, on the other hand, that is like a subgroup of IoT, but is specifically geared towards industrial and manufacturing environments. So it has different needs because you have to have enhanced processing power, efficiency. You need to have a more safe and robust type of structure. You have to have a good energy management and stuff like that. So everything needs to be a little more robust, so to speak. The main differences are scale and complexity, of course, reliability and safety. In our everyday use, a downtime for us can be more of an annoyance, but when you are going industrial, you can have a really huge amount of loss of money amount if you have a downtime, or you can even have safety hazards and stuff like that, so you need to be careful about that. Then you have data management and analysis that are typically different in these two areas because you, as an industry, you need to have you have a lot of data to manage, and you have to make analysis, maybe for predictive maintenance, for example. There are also differences in network and communication protocols. So there's in industry, most of the time you have protocols like Modbus or OPC UA and other protocols like this. I would like to talk to you about the first tool, that is Raspberry Pi. That is a small and affordable single-board computer developed by Raspberry Pi Foundation. It was designed to promote teaching and learning in computer science and programming, particularly in schools, but it turns out it's actually good. It can be good in small to medium scale applications. It runs Raspbian as a default operating system. It's supported by a robust community that contributes with documentation, and there are a lot of forums, tutorials, and is easily programmable and can be used with for a wide range of projects, from simply monitoring system to complex industrial setups. So it has a lot of it has a good connectivity because it has a lot of interfaces. It's expandable. Its processing power, of course, you can't use that for 3D modeling, for example, but you can have enough processing power to process information, and it has a really low power consumption, for example. There are a huge plethora of different types of raspberries that you can use depending on what you need to do. And on the right, you can see a more robust type of industrial-focused Raspberry Pi. For example, it also has an RS485 interface on the bottom. And why is it good? I'm not telling you to swap all your PLCs with Raspberries, that's not the case, but it can be good, as I said, for small to medium scale operations. So one of the main good things of Raspberry Pis is that its cost effectiveness, because it has a low cost, it's flexible and versatile. You can also actually have an all-in-one solution for data acquisition, control logic, and communication all in one package. It has no proprietary hardware software like most PLCs. It's easy to program and to integrate because it's compatible with widely known programming languages, and it can be integrated with Node-RED, for example, that I will talk about it more in depth later. And you can use Python scripts and all that kind of stuff. It's customizable because it's pretty modular because you can go from a simple monitoring to an advanced automation interface. It's adaptive, and one of the greatest pros of Raspberry is that it's an open source. It has open source advantages like no licensing costs and can promote in this way innovative solutions. The second tool that I'm going to talk to you about is Node-RED. I don't know if you already know what it is, but it's actually a flow-based development tool based on Node.js. And it's designed for wiring together devices, APIs, and online services. It has a message-driven architecture, and each node represents a discrete function or operation. So you can, with these nodes, you can actually control inputs, processing logic, and outputs. You can have MQTT messages from sensors. You can process it and processes them with nodes, function nodes, and you can actually have outputs for actuators, relays, for example, or databases if you need to store this data. This model allows for asynchronous operation, enabling multiple processes to run simultaneously, which is a pretty good thing. And it includes a variety of built-in nodes for HTTP requests, MQTT communication, database interaction, and more. Its flows can be created and easily deployed on Raspberries, for example. It supports various industrial protocols such as Modbus, MQTT, or OPC UA, and this compatibility helps to bridge the gap between modern IoT solutions and existing industrial infrastructure. It's easy to use. First of all, one of the main reasons it is good, it's really easy to debug and monitor because of its flow-based nature. It's easy to deploy, and it's also highly scalable. It has a flow control and logic. It's compatible with a lot of protocols. It has remote communication and control. It has a lot of different options. And as I said, there's a great community that helps to improve it every single day. Now, I would like to share with you some of the examples that I made for this call, and also some examples that are from past projects. For example, this is an interface for household monitoring. You can see there the temperature. I don't know how I can point. I don't know if you can see it.
Point towards the...
Okay, sorry. You can see the temperature, humidity, AQI, air quality index, light, and here it's a little bit small, but it's a presence LED that tells you if there's a person or not. This is typically a this is just the front end. There's a back end that you're not seeing, but it's a good solution for domotics. And you can also apply this for building automation to scale it up. So you can just copy and paste it and apply it to many different sensors in many different departments, for example, and you can have a building automation project, so to speak. One of these, one of the great things that is that when you can go from a smaller project and gradually scale it up, and by doing so you can just reuse the same fundamental, the same logics that you already used. For example, for air quality data, you can actually use these logics to, I don't know, you can apply it for a project where you need to monitor air in hazardous environments, for example, but just by tweaking the code and tweaking the flow of Node-RED, for example. This is an example. It's a screen that I took from a video that from YouTube, and you can see the link down below. Is a more SCADA-like interface that is more familiar for automation users, and you can actually download a lot of different contributions in the UI department and also the backend department to meet your own needs. This, for example, is an example of a flow that does remote control. You have an MQTT commands that are listened by Node-RED and are going inside this function node for function 43 node, and it functions as a filter in order to these are executable commands, executable bash commands. So you can actually, I personally use them for executing bash commands on a Raspberry Pi that was in the production camp, and this was a MQTT out for to catch the IP or its normal IP and the VPN IP after tunneling. This is a more, so to speak, complex temperature control with hysteresis. We have a flow that starts that initialize the variables to start from a known status. Then we have the temperature read once per second. This was done with an SHT31, if I'm not wrong, that was connected with I2C. And there's a group of temperature control that cycles once a second to read the temperature control. This system actually actuates a relay. There's a relay connected to a pin of a Raspberry Pi. The LED says if it's on or not, and you can actually use a set point of temperature. What it does, it's activating on and off a relay with the help of hysteresis. You can have you won't have the on-off continuous on-offs. You can actually control the heating for industrial applications or even for other type of projects. And this is a simulation node that I use to actually try to test it, because I didn't have the sensors at the time. So you can actually inject with an inject code. You can actually simulate what you need from when you actually know what the sensor are sending to you, you can actually do some testing like this. And it's a pretty good solution that we use to control an eating machine in industrial applications. So I would like to thank you all for watching. I ran out of time. I have 30 seconds left. I hope my information were useful to you in some ways, and I thank you all for being here today in this wonderful situation that NOI TechBot created. Thank you.